So good afternoon again, and I would like to thank the representative of the 5GTimber project for being here to provide valuable information for this challenge. I thank, of course, also the participant for being here to join us in this event again. I remind you that the event will be recorded, so the people that could not join us this afternoon will have the opportunity to watch the event later and tomorrow, for example, because our guys frequently ask this possibility because they have lesson also now in this hour. The agenda of the event it was already presented just before the recording was started. So at first, a brief presentation of the 5GTimber project. So I think that I'll hand over to Professor Lemulek from Taltech. Welcome, Professor. Thank you again for being here.
Yeah, thank you very much, everyone. Thank you for the opportunity to present our challenge. Thank you to all the students, future participants of the Manuthon event. I was wondering, Marcello, would you share the slides from your site? Yes. Okay, yeah, thanks a lot. So in 5 minutes, I will introduce our 5GTimber project, which is, let's say, the umbrella project from which the challenge that we are proposing is coming from. So next slide, please. So this is a European project, as first information, and it is under the theme of the transition to 5G mobile communications and Industry 5.0. So very general thematic, and this is also known as the twin green digital transition. So this is a major topic which is promoted by the European Commission, and the idea is to combine advances in the digital transition, so all modern technologies, 5G, digital twins, extended reality, and so on, combined with the intention to have more sustainable, greener production manufacturing systems. So the idea behind this is to enable greatly accelerated digitalization and circular development models for both producers and consumers. And obviously, the wood industry and the wood-based manufacturing is a part of this transition. So it's a very nice fit that in this project we have this wood-based topic. It fits very nicely in this theme. So the 5GTimber project in itself is co-funded by the European Commission. It runs from 2022 until 2025. So we have a bit more than 1 year left in the project. And there are 16 organizations from 10 different countries. So we can see in the figure on the right-hand side, European map, and we can see where those different partners are located. So I'm not going to read each and every of them, but we can see that we have a very nice distribution across Europe and also a nice distribution between academia, research-oriented organization, and companies. And I maybe already want to highlight now, we can see that in Estonia, we have Harmet as the company who is supporting the challenge, which is presented today. So we'll hear more about them in a few minutes. In the project, in the 5GTimber project, we have multiple disciplines. So we are combining wood material models, digital twins, augmented/XR, extended reality, 5G, and some other modern technologies. And one of the central ideas is to help small and medium enterprises to optimize their workflow, to reduce the waste, to improve safety. So these are key aspects that will be further developed in the challenge. So we want to work across the entire wood value chain. And on the next slide, we'll see a little bit more about this. and also where the challenge is in this wood value chain. So what we see on this figure here is that the project starts on the left-hand side with the wood logs. So we don't start in the forest. The logs are already like cutted and arriving at the sawmill. This is what we call the pilot 1, or sometimes use case category 1. So in the sawmill, the wood is cutted into pieces of wood, timber, and this then goes to pilot 2, which is the production factory. So in our case, it's specifically modular wooden house factory, so Harmet, in which there is a 2D assembly and 3D assembly of the modular wooden houses. And after that, there is pilot 3, where we have the construction industry. So basically, those modules are taken to the actual site where the module will be installed. And there is still a little bit of work to be done there, even though in the project we try to do as much as possible in the production factory. So in the projects, we have different key innovations, which are a bit repeated here. Some of them already mentioned. But in addition to the core technologies, we are also very much interested in the open standards for production, especially in terms of data representation and the exchange of the data. It is also represented on the figure. We can see that some data passes from one pilot to the next one. So the idea is to keep track of the different properties of the wood, starting from the logs to the wooden house manufacturing, to their installation and possible refurbishment, recycling later on. So with that, I think I have provided a general introduction to the project. And on the next slide, there will be the more specific introduction to Harmet, which is supporting the challenge. Thank you very much.
Good day, everybody. My name is Mari, and I'm a 5GTimber project manager in Harmet. Harmet produces timber-based modular buildings since 1997, and we offer complete solutions from design to production of the modules to the assembly of these modules on site. But before I tell you a bit about Harmet, I will share a bit of insight. What is modular construction? As you know, traditionally in the construction industry, the buildings are built on site. But in the modular construction, the prefabricated modules are produced in controlled factory environment, and these modules are then assembled on site. These modules have either metal, timber, or hybrid structure. And in our production, the first stage is the production of 2D elements, and out of which these are put together into the 3D module, which you can see on the upper picture. The windows and doors are also installed in the factory. During the same time when the modules are being produced, the site works are also being done. When from the factory, the modules are transported to the site, and on site, these modules are assembled next to each other and on top of each other. After that, the connections between the modules are being made, and additionally, the HVAC and the electrical systems are also being assembled. And then the building is ready. If you could put the next slide, please. Yes. So this is a very good example how the assembly of a 3D module on site looks like. Next, please. What you perhaps do not know is that Estonia is the largest exporter of prefabricated buildings in the whole Europe. Next slide, please. So a bit about Harmet. We're the largest producer of modular timber buildings in Estonia. Our monthly production capacity is between 600 and 800 3D modules, depending on the product we are producing. Our Kumla factory which is located about 20 kilometers from our capital, Tallinn. It has a shop floor size more than 23,000 square meters. And on the photo on the slide, you can see the inside of that factory floor. So it's quite big. Our turnover in 2022 was more than 114 million euros. Next slide, please. And this is the outside view of our production facility. Next, please. Our products can be divided into three main groups or categories. The first are the site hubs, which are quite simple products, which are used on construction sites. And these we are capable of producing around 800 of these modules per month. The second group are the semi-permanent modules, which are used to assemble schools, kindergartens, offices, and accommodation of workers. And the third group are the permanent buildings, which are, let's say, like the regular buildings, apartment houses or student houses, and retirement homes. Next slide, please. I will share an introductory video of Harmet. I'm not sure if the sound comes through, but I'll mute my microphone, so maybe it will happen. Marshall, maybe you have to share your sound.
It seems there's no sound apart from my computer. I will try. I don't know why it's working. Let me try.
And building for your dreams. Harmet values your time by offering you the opportunity to plan and build faster and more efficiently than ever before. Harmet offers our clients complete solutions, from design to the assembly of our buildings. Our rapidly evolving company began producing prefabricated modular buildings in 1997. Our product range includes various modular houses, building elements, modular on-site facilities. With a team of over 600 personnel, Harmet operates in 4 factories with total production area of 45,000 square meters. The total annual building capacity is approximately 200,000 square meters. We provide prefabricated modules. Around 90% of the entire building structure and the interior is manufactured in our factory, which offers the most optimal and safest conditions for construction. Harmet's primary market is Scandinavia, and more than 95% of our production is sold to Scandinavian countries. Close to 70% of our production is delivered to the Swedish market, with our primary customers being Kramo and Buklug, IKEA's and Skanska's joint venture. Harmet employs more than 25 engineers. We use BIM technology, available software, HSB CAD, Tekla BIM Site, ArchiCAD, MagiCAD, and AutoCAD architecture. We carry out building elements, technical drawings, water sewage, heating and ventilation system design, also electrical system design models, and project management of the design. Our products come with all doors and windows pre-installed, with all interior finishing and most of the exterior finishing already completed, with complete power, water and sewage systems, with all sanitary and bathroom appliances already fitted, with a pre-installed ventilation system, with pre-installed kitchen cabinets and appliances. We can also install all furnishings, and all modules undergo quality control before leaving the factory. Our products feature high-quality construction materials, which ensure a long service life and reduce future maintenance costs. Harmet's products come with up to a 5-year warranty. In March 2010, Harmet acquired a Pan-European Quality Certificate, ETA 10/0030, allowing the design and assembly of wooden houses all over Europe. Harmet is also environmentally active by planting numerous new trees every year, helping to renew and regenerate forest and woodland areas. In 2017, Harmet opened a brand new factory at Cumnar, Stony. With 22,000 square meters of production area, it will provide an output of 350 modules per month. Modern technology lowers production costs and raises volume levels, which is a great step towards satisfying our most demanding customers. With Harmet's wide product range, from portable on-site facilities to modular building elements and modular houses, Harmet offers you the opportunity to plan and construct for your wildest dreams. In no time.
So, Mari, if you don't have anything to add, I will continue.
No, thank you, Marcello.
So, thank you. I will take the stage now. I'm presenting in English. Well, I'm Italian, so in case any question arises, both me and Simone, we can speak Italian, so we can support in any case. Yeah. So, thank you for the colleagues, and thank you, Mari, for the availability to be a use case for this challenge. I will briefly present here the motivation and a description of the challenge that we are presenting to you. So the motivation is twofold. The first kind of motivation is technological based, because I mean the project has 5G in the name because it is leveraging 5G technology. So a new generation of cellular communication that provides some advantages. So some of the advantages are quite common. I mean, it's faster, it provides a lower latency, it can bring more data, is able to match the communication between a lot of devices for IoT, and is also power efficient. And it is expected, nevertheless, that it will have a huge impact in the whole industry, and specifically manufacturing. While with an increased revenue, I mean, the forecast is 131.8 billion in the next year of added GDP. Why this? Because it enables some technologies like AI, XR, and 5G, due the possibility of bringing data wherever, also in remote location, at a fast speed, and also with low latency. And this is a relevant requirement for XR. What we are addressing in this project, that we are sure that will be larger industry that will leverage this technology, but it's also true that smaller companies could also benefit from this, given that they are provided the right tool, the right technologies, and the right instrument to be implemented in their factory. And this is why we are working on this in this project. But there is something common for the people, not so understandable for the people that are not working the technology. And it is the possibility of using public network to create sub-network that are good for offices, for laboratories, or for companies. And this is what we are leveraging in the project. So there is the possibility of creating what are called private 5G networks, so you use 5G technology to build a private network in a company, or you can use hybrid network where you have the same 5G infrastructure that provide both public network for us using our mobile, and for companies allowing a slice of the network to be private. So rather than implementing cable network also in larger plants, you can use 5G technology for this. And this is why we are demonstrating the use of XR as an example. That will be one of the main technology that we will address in the challenge. The other set of motivation derives from Harmet. So Mari presented the amount of product that they are selling all over Europe and specifically in Scandinavia. And I mean, as you can see here, there's also, beside the huge amount, there is also a very rapid increasing on the volume that have to be produced. And this has a clear impact on the way those modules are produced and the factory that has to take care of this. And so the main motivation, industrial motivation that we'll address here is that Harmet provides a wide range of products. You have seen of many different kind of modules and where they are used. There is a wide range of different typologies, but they also allows customization. So they provide furniture, electrical and water installations, and specific configuration from the customer. So we can say that each module could be different from the others, and this provides an extreme complexity in the production system, and consequently the risk for errors, because most of the activities are executed manually. The second thing is that if you are producing different products in the factory and they are changing from day to day, the logistics of both material and the people and the transporter that are moving inside the factory can be complicated. And this is a possible source of dangerous situation in the shop floor because you are handling heavy components in different places. And so this is also a strong motivation to use digital technologies to support safety. How so 5G technologies and digital technologies in general can help? Well, there are two main directions that we are pursuing. The first direction is bringing to the human operator the best information that they need. So instruction, drawings, data information, so that in the shop floor, while they are assembling the product, they can access this information in a really easy way. And XR, so extended reality, is one of the technologies that we're addressing in the project, because 5G technology enables this even more in shop floors. And the second thing is also addressing indoor positioning, so checking where the things and the people are, or the distances between the people and specific objects like transporter, with the idea of enhanced efficiency and safety. And overall, we expect to improve the work efficiency, because if you provide the right information to the worker, that we behave more efficient and more effective, and also reduce the associated accidents or near misses, because safety is not just trying to avoid accidents, but also try to avoid situations where the accident is about to happen, and those are called near misses. And this is even more important, because if you can avoid this, the risk associated to accident is reduced. So the core of the challenges is using extended reality to support people and check their position against some of the dangerous situation in the factory, specifically the handling of materials. And so the idea is bridging the gap between the real factory and the digital factory that contains all the needed information and the monitoring of what is happening, to enhance the productivity and mitigate the associated risk. So you will take advantage of the technologies and tools that we are developing in the project. So you will have an XR technology environment ready to use to prototype. And you can also use some technologies leveraging XR for precise localization or localization of objects. So the core of the challenge is to use extended reality and localization technology, especially QR codes that can be seen by the XR devices, and identify object and estimate the distance. And the idea is to support human operator while they are assembling those modules. Well, the proposed solution is expected to bridge the gap between the digital and physical world, mitigate the risks and enhance the productivity, and demonstrate that the proposed solution can increase the productivity and reduce the risk for accident. What we are expecting from you, well, a presentation and documentation of your proposed solution, and possibly a demonstration. So you will see that we will bring to you some ready-made tools, or even not so ready-made, available for prototyping. So the idea is that if you want, you will be in the condition to play a little bit with those technologies. We have been adding here 2 slides with some suggestions for the challenge. I mean, those are good here, but could also good for everybody, because, I mean, you have a very short period of time. Challenges are really broad. So every time, please define clear objectives. So you have a general objective, in our case, is increase productivity and increase safety. But in order to achieve those general objectives, you will have some specific objective. And try to be really clear when you structure your work to define what is the general objective, the high level one, and what are the specific one, because it allows us to understand why you are focusing on something and why this is relevant for the general objectives. The second suggestion is try to look around if something already exists, because, I mean, technologies is running really fast. So have a look on the internet if something is already available for this. And if it's already available, try to leverage it on this. So let's not repeat what already exists, but try to say, okay, I saw that there is this technology. I can use this technology together with this one to bring you a solution. Try to focus on innovation or on what is different, so what you're actually bringing to the problem. So trying to highlight to what extent and why and how what you are proposing is different from what is already available. And if you want, create a demonstration, but try to focus the demonstration on what is actually valuable. So you don't need to demonstrate what everybody knows is already existing. If you have some nice idea, new idea, and you want to show that this could be usable, try to focus your demonstration on that so that you can convince the company and who is listening to you that this is a viable solution. So you will have companies in front of you that will listen to you and evaluate your project. So try always to highlight why this is relevant for the company. And secondly, try to assess how it could be good in terms of, in our case, increase the productivity or reduce some cost. It's true, we all know that you don't have all the detailed information and data, but at least try to highlight the criteria that you are using to make some estimation. So if the criteria are correct or they're sound, just putting the right data there will bring a sound estimation as well. Okay, that's all from my side. So I will give the stage to Simone and Ivan that we will present some of the technologies. Please, Simone.
Yes, hello everyone, and you can go forward with the slide. So basically, we're going to present like technologies related to especially what was presented as XR application or utilizing XR in this context and leveraging 5G technologies for supporting operators. And this was developed for a Harmet use case. And so basically the main goals, as already mentioned, is are having dynamic visualization of component models and the ambition to use augmented reality on the production field to support operators in the assembly steps. So the visualization of the models goes together with the information related to each step and each material in that sense. This should be connected to, in the initial idea or within the 5G project development repository, handling the informations and handling the informations also through, let's say, the design department of the company to have like this loop closed between design and production. And the idea is just not supporting the operators and improving the efficiency, but also reducing problems and mistakes that can be on the production field or during the assembly. So the non-conformities there, which can be then, of course, reported and fixed on design phase and in the 3D models. Regarding the tools, I guess Marcello can go on, and I give the floor to Ivan, who can explain more which were the packages and tools used for this application demo.
Okay, hello. Hope you can hear me well. So I'm Ivan. I'm a project specialist and the basically developer in the research group at Altec, working with XR technologies. So for this particular project, we decided that the most reasonable way to proceed would be to create a web application, because those are highly available and easy to change, modify, and play around like in real time. Yes, of course, it requires some coding skills, but actually with modern libraries, it's quite easy. You have predefined building blocks which you can use for prototyping and quite fast to implement. So for this particular project, we were using Next.js, which is one of the most popular frameworks for web applications, because we were building not only the interface, but also the interface for users. Tailwind CSS accompanying the Next.js, and the very famous 3GS library, which provides 3D visualizations for any kind of web applications and has built-in AR functionality natively accelerated by most of the devices, meaning that we can use either phones or headsets. Actually, we could bring some of them to the Manuthon together with us. And essentially, you build it once, and you can run it everywhere on almost any kind of device inside of your network. Next slide, please. Yep. So while we're building this application, we were focusing primarily on the Harmat's requirements in terms of what they actually need, because having a digital twin, meaning the represented state of your system or production, is nice, but you need this kind of last mile delivery, as it's commonly said in logistics, meaning you need to merge this nice and well-structured virtual world with the human operator. But the human operators are sometimes tricky to work with because they are unpredictable, and they need a very user-friendly way to be able to discover the data, see the data, and somehow match it with going on in here. So the XR was probably one of the most perfect choices, and especially that we have very fast connection for real-time data transfer inside of the shop floor. So the process which we done for the Harmat's use case was basically creating a as you can see on the diagram, feedback loop between the designer, the server where our application is running, and the operator, which helps the operator to know what basically to get an answer to the question, what do I have to do next? So anytime the operator wants to know what would be his or her next steps, he or she can just enter the application, get the relevant step and 3D model, probably from the point where the operator has finished it. And in case there are any issues, the person can pinpoint on the real or 3D object visualized in the app the problem, because it's very common that, for example, some model is of not proper size or the instruction is not matching with reality. Then it would get the real-time notification to the designer. The designer will take appropriate steps and then update the user with like new instructions, new 3D models inside of their personal applications. Next slide, please. Yeah, so for this use case, that was a simplified architecture. It's kind of complex. You actually, for the hackathon use case, if you need to build a quick demo, you can do the same thing which we were done in the first like months of the development. You can omit all the backend functionality for data fetching, but you can still build the web application, which is marked with this letter N, Next.js, for operators. So essentially, it is hosting a website with like some of the pages which are immersive, meaning that you can run the XR scene from there, walk around with basically navigate there with your tablet, then run XR mode, and then walk around and see what is there. And multiple operators, dependless on the device manufacturer which they are using, whether it's a tablet or mobile phone, can connect to the basically like a website hosted inside of the network and experience the like functionality which we provided for simplifying their job. Next slide, please. Here you can see a slide of or a screenshot of our operator's production step, where you can see the expected result. Actually, this tool also allows us to use simple 3D visualizations, because sometimes it's easier to understand, but as soon as you need to get a closer look, you can go to VR. Yeah, so you can see aside there is a set of materials and task which operator has to do at the point. Next slide, please. Yep, also like the overall instruction, what the person's task would be for the day. Next slide, please. Okay, I believe that.
Yeah, this
so
basically you explained already in the previous diagram.
Okay, I thought that the screenshot with the XR was missing, but I hope participants can trust us that all the views which we showed before can be also run in VR. And actually, we even made some tests, and the person could walk around with the tablet and see all these parts like placed inside of the local floor, and as if they are real components, but they can also like look through it in case a person wants to walk around or see something. This is basically the flow, how the logic works. It's a bit different from classical XR apps where you have a standalone application on your device, because in this case you would need to build it every time, and the development would take a lot of time. So this is the way we propose to use the solution. Basically, this utilizing web technologies or making the thing as a web application would allow us to make rapid development, meaning that you just need to save the new version and it will be automatically updated in all the devices listening to the website. Here you can see the interactive demo. It's probably not the latest version, but that's the application, how it was working. Here you can see that we can like explore the model in 3D. You can navigate over the steps from here, so you can see what would be the task for this current step, what materials are used. Yeah. So typically in production floor, people are doing, and then they asking what to do next. And also here there is a report form for non-conformities. It's better to use with a classical form sometimes, as it was done at this step. But it's sometimes acceptable if the user testing shows that it's more intuitive for a user. Yeah, the second use case, which we are also developing under 5G product, but for a slightly different company, is a maintenance assistance for operators, basically, but it's for rather technicians. So this tool allows you to place the 3D cards on top of real objects, basically in real time. So the tablet can see the markers, especially the frame of video feed from its frontal camera, and position the card with instructions on top of it. So this might be another use case which you might want to use in the hackathon,
or integrate the same,
or integrate the same functionality. It was not done as you can see here in Harmet's use case, because in dust and not constantly lit environment, it causes some implications, but maybe in the nearest future it will be there as well. So that was, I think, all from our side. And if you have any questions, we would also share with you, or with the organizers, and they could share with you the guide to this technologies.
Tools,
I know those are not like very, those might cause some complexities because they require coding skills. But I've created like a detailed guide with the motivations, basically, which we typically give it as our internal resource, but we are willing to share it with you. And if you have any questions regarding that, you can contact me with my working email, which I will provide as well there. Thank you.
Thank you, all. Yeah, Chiara, that's all from our side. We have a package of material that we'll make available for the student. So some slides, this presentation, some link to the documentation so that who is interested can start looking at that. Please, Yannick, go.
Yes, thanks a lot for the presentation. I just wanted to mention, and I hope I'm correct, that Ivan and one more colleague have planned to be in person during the Manuthon event, so it will be great support for the participants. Yeah. Myself, I've also promised that if possible, technically to have a remote connection, I will also be available during the 2 days, so I'll be supporting, but remotely. So it's not that we are just providing a bunch of documents and we let the participants try to solve everything by themselves. So we'll be there to support either on-site or remotely. And last small comment is perhaps to try to clarify a little bit why we had this last video, which indeed, as Ivan explained, this is in the project, it's for another use case. It's for the machine, let's say, maintenance. But the idea for the Manuthon is to combine this to the extent possible with the previous example. So using those QR codes and this kind of technologies to also estimate the distance between different objects on the floor plan to be able to detect the distance and to have those detection of possible collisions and increase the safety. So obviously it's not exactly what we're already doing in the project, but it's building upon what we have so far and combining them in a possibly a new way. Thanks a lot.
Thank you, Yannick, for the clarification on the distances. Simone?
Yeah, no, yes, exactly. I wanted to add to that. I guess, Marcello, you refer also to this document Ivan prepared with things. Yeah. So please, to everyone, then we'll join the challenge here. Just go through and check out all the tools there because they are essential for the development. As Ivan mentioned, is usually there are frameworks which have like building blocks which are easy to implement and understand, but they need like depending. I see Ivan like commenting with the head, but depends what you want to do as well. And they were not used for implementation. This QR code example you see, it was a different framework. So this will be part of the challenge as well to find the correct tools for that, because we never use it for at least internal development for localization. So please check out the document, check out the informations there, and exactly like Yannick said, Ivan and Rostislav will be around during the hackathon.
If there are any questions from the participants, if you want, you can use also the chat, and we also in Italian. It's not a problem. We can translate or use our Italian colleagues to explain any doubts or.
Sì, anche se ci sono domande in italiano, poi ci occupiamo noi di tradurre. Io e Simone lo parliamo correntemente.
Direi. And just to understand, the material is already available for the guys, so we can share from, I don't know, this afternoon, tomorrow, or now, or you intended to bring directly to Manuthon?
No, I have a package of material that I'm sending you together with the slide that could be shared starting from this evening. Yeah.
So I will share everything by email from Info Manuthon just this evening, so you can start to study some material.
Posso chiedere una cosa?
Certo.
La chiedo in italiano così giusto per essere chiaro. E quindi, cioè, la sfida è quella di utilizzare, quindi da quello che ho capito, questa tecnologia che già si sta utilizzando con delle nuove applicazioni, diciamo, o cioè estenderle e basta?
No, la sfida è più ampia, nel senso che si vuole affrontare il problema di dare supporto all'operatore e migliorare la sicurezza. Noi vi portiamo una tecnologia che stiamo usando, voi potete usarla, è lì. Se la usate ci piace molto, se avete delle idee migliori, penso che siate liberi. Se volete prototipare qualcosa, avrete lì le persone che sanno mettere mano alle tecnologie, ai dispositivi, qualcosa di già impostato su cui potete aggiungere dei dettagli o sfruttare per altro, ma se avete idee più interessanti siete completamente liberi.
Sì, infatti posso aggiungere anch'io questa cosa e direi che appunto questi sono esempi di come queste tecnologie sono state usate in un caso d'uso che aveva determinati requisiti per la compagnia Harmet e per quello che serviva loro, e poi, come dice Marcello, possono essere utilizzati flessibilmente oppure no per risolvere problemi simili negli stessi casi d'uso, insomma, quindi di supporto agli operatori, sicurezza, localizzazione, eccetera. Voglio chiarire che non sarà usata l'applicazione che voi avete visto, perché questa è sviluppata per la compagnia, per la Harmet. Ci saranno, nel senso, i software, appunto la documentazione sui software. E poi appunto Ivan e Rostislav saranno presenti per supportare lo sviluppo se ci dovesse essere appunto tempo di fare un prototipo, insomma.
Ok, grazie mille.
Prego.
If none of the participants has any question, I would like to ask something. It is specifically...
Sì, ho una domanda.
Oh, ok.
Salve. La mia domanda è: la discussione, e quindi anche l'elaborato della discussione, qualora scegliessimo questo caso, dovrà essere fatta necessariamente in inglese?
Come preferite, nel senso che... So, Yannick, the question is everything has to be in English or not? The report, the presentation?
No, I think no, we have to be open-minded here, and I think even though we are an international consortium presenting the challenge, since it's an Italian event, I think it's fair that participants are allowed to do it in Italian, and if there will be like interesting results, and we hope there will be, then we'll take care of translation within the consortium.
In ogni caso,
Grazie.
ci sono io e Simone, io Politecnico, Simone...
Io non sarò lì, Rostislav e Ivan parleranno solo inglese, io non ci sarò purtroppo.
Comunque ci sono le persone che parlano italiano, quindi possiamo aiutarvi in ogni caso, e anche se volete interagire con Ivan o con Mario, con gli altri, possiamo aiutarvi noi.
Perfetto, grazie.
Any technical question or doubts? Maybe from Gabriele, you had some curiosity.
Well, I would have quite a lot, because it's an interesting project, and also all the manufacturing process, it's really large, and it seems to me that it comes from the log to the modules assembly and also to the building assembly. So I was wondering which are the technologies that are inside your manufacturing process. I mean, I guess you will have finishing or of metal, maybe, or bending of the metal. Do you use treatment for the log with oil or painting? It seems a very large process, so I would like to know which are the phases in which the augmented reality could be used.
Who is replying? Mari, you want me to say something? You want to say something, Yannick?
Well, we discussed, Marcello, an option perhaps to share the some of the factory floor plan with you. I don't have it prepared yet, but as we don't have a bending machine, we don't have a painting chamber in our production. It's more like work on production lines. But Marcello, perhaps we managed to put together a floor plan with which would give an overview and maybe a short description, which is the 2D area where we produce the 2D elements, after which the elements would be taken into the 3D area.
Okay.
But
I think
the main use of those XR technologies in the assembly. So they cut components. Most of the components are wood. They cut in parts. They build the wall, the floor. They then assemble everything together. And in the assembly, that's the most complicated part because you have the building, water installation, electric installation, furniture, windows, whatever. And so, I mean, as this could be different from the different customers. It's complicated for the different operators to know where the water plumbing is, where the electrical installations are, and what should be installed next, grounding on that project. So the main focus is the assembly. In the project, we also have a focus of using the same technology at the construction site. So when the building is being installed. But here for the Manuthon, we want to maintain the focus in the factory.
Okay. Thank you.
You're welcome.
I also have a question, but for example, it's the same operator that has to build the module, the frame, and also the plumbing, the electricity, or they are different people? So they are very trained to do only one task, or they are open for all the assembly?
I would answer to that. Yes, we have different teams, meaning that the plumbers and the electricians and everybody who has a, like, let's say, like more specific task, they're different teams, meaning also if we have to put the PVC or the tiles to the floor or even the furniture team, they're different. What is the biggest workload perhaps, as Marcello already described, is to if we make, for example, a wall element on the production line, it is putting together the timber, let's say the pieces of timber, putting them together and then adding, for example, rock wool, different layers needed. So it's a quite complex, let's say, a wall structure, meaning there would be several layers, and then maybe you saw in the video also when making a wall or a ceiling, it is often also turned during the production because you can't do it everything from one side. So it's yeah, but as Marcello described, the challenge is that the variation of products is we produce, it's quite big, meaning we don't have 5 types of products, we have tens and tens. And there could also be variations from the client side.
And concerning the safety problems, so because you say that the augmented reality could also help to solve some of these near miss or even stricter problems, but they can be always the same. So you have a categories of these safety problems or not? Because it's quite difficult, I think, for the participant to understand what are the risks related for this variety without seeing how the building are assembly or built.
Marcello, maybe you can comment on the safety aspect.
We will provide something during the challenge. It's complicated to share the video of the assembly in all more detailed information, but so basically the major source of risk is the handling of the parts. Because, I mean, they are building modules and they are building the modules in different places in the factory. So there's no specific location in the factory where the same operation is always happening. So once you need to move a wall in that direction, the other time you need to move a wall in the other direction. And so the safety area, when the handling is operated, has to be changed continuously. So there's no line on the floor that can be used to as a border for the areas. But every time, I mean, the operator has to take care that nobody is in the trajectory to do the handling, because the handling is changing every time. And so this will be the major considered source of risk: transportation and handling of parts with overhead cranes or with other kind of transporters. That's all.
And one thing, because I'm not sure to have understood, do you have also something physical to bring to Manuthon or not? Because I'm not sure to have correctly understood.
Well, we cannot bring a module there, I think.
No, not a module, but some tablet or...
Ivan, you are going to bring a tablet and some devices.
Or
yes,
some devices
I think we can.
to wear. Or...
Yes, I
can take. Yeah.
You can take like several wearable devices, these Oculus 3 headsets, which supports augmented and virtual reality for maybe potentially more interesting use cases.
Yeah, and maybe a tablet, but for sure, a couple of headsets or 3, depending on availability.
Thank you. Just to understand how the operator, what they have in their hand using this augmented reality. From my side, I don't have any question, but I don't know. Obviously, the guys can ask for everything from now until Manuthon every day. I can also share your question with the 5GTimber representatives whenever you want, so it's not a problem. Who will be here physically in during the event? Marcello?
Ivan?
Ivan and Rostislav.
A colleague from Ivan and probably another colleague from Polyme.
I've seen that there is a question. Is the assembly done in a fixed position? Is it continuous moving or else? It's from the chat, so if you want...
So maybe it helps if we make this shop floor drawing where we show where the 2D elements are made. But yes, the elements are made on a production line, meaning that they move. That one team will finish their step, and then it will move to the next step. But it's not as fast as you would maybe see in some other productions. But if we talk about the 3D assembly, then there it's also done like this, that each, let's say, a house or the module, the closer it gets to the exit, the more ready it is. So they will perform the same steps for each module, and then they will move the modules. So the one which is ready goes out. They will push it. It's kind of like on the train, like on a train, these lines, and then they will move these. They will do the same things, and then they will move again. So I'm not sure. Maybe a drawing would definitely help to understand, because without it, it might seem too abstract.
So in the picture, you are showing a specific step of the production, for example.
Yeah, this is showing towards the 3D assembly, where the 2D elements are already produced. This is the one which you can see in that one. This is, for example, a wall. And when all the 2D elements are ready, then first they put the floor, and then to the floor they add the walls, and then when the walls are ready, they put the ceiling on top of it, and then the exterior, or let's say the frame, is ready, and then they will start with the interior works and to add some of the exteriors if some profiles are missing, if some connecting joints need to be something needs to be hidden, etc.
So Mari, and then those are moving towards the end of the plant. While they are assembled, they are moved away until they reach the end of the line. Let's call the line when they are moved to the outside or to the customer. So to reply to Paolo, it's not a continuous moving, but it's moving on a step-based mechanism.
I would have another question, but how customizable is the models? I mean, as a client, I can come to you and ask for round models. How deep can I go with the customization of your product?
We don't
Do you have an average production time, assembly time for your line?
We have limits which are regarding the size of a module, and also it depends on the engineering department and the transportation. In that sense, that the limit is also connected to the size of the door, but also that to be honest, transport is even a bigger issue, because if we talk about that we are transporting ready-made 3D modules, then to have extra wide or extra long module to be transported on a road, then depends of the road, etc. But of course, we don't produce round modules, and also we have height limits. But just to give an example, one of the recent products we do to one of our clients is it's quite long. It's I think it's like 16 meters long. And it has some other challenges. So I think the engineering is also, the engineering department has to say what is doable and what is not. But
it's not.
Yeah, and of course there are some solutions which are maybe there's no point to do it out of like timber. Let's say, for example, if a client says, I want a glass house, then our factory is not the right producer for it. Of course, we're flexible regarding the facade material, etc. But and as mentioned, some of our modules have hybrid structures, meaning that we also use steel pillars in some of the products corners, and some products also have a steel frame under it, especially the side huts, because then that makes lifting of these modules easy, because they will be relocated on sites, and the rental period from the end users, they could be quite short. So this is like a like the typology, but and also, like, if you ask about what limits we have, yeah, depends on the engineering solutions, because some of our clients come to us with let's say like pre-engineered solutions, meaning that they have the like the structure, or they've done some initial structural design, but we also do the product development ourselves. So or you're thinking more like measure wise.
Fine. And also, how do you work with a push or a pull logic? I mean, you wait for the client to ask for a models, or you produce and then sell? Because it's you have products that can from site ads and permanent building. That's quite bit different as I mean, as production volume required.
Mm-hmm. We don't sell, or we don't rent our products ourselves. So we start producing when we have a client, when we have a project. Of course, we
all the products.
Yes, and we only sadly we don't sell to private customers, meaning that we have a minimum amount which we order, because otherwise it would be a custom-made product, and then there wouldn't be a need to have such big factory. So we're aiming for big amounts.
Okay, thank you.
I think that maybe we are almost because the time is quite finishing, but of course, if you have any other question, we are here to solve the first problem. Then the real one will come on the 19th. I think that maybe for now we are maybe we can conclude our meeting.